qualitative analysis problems, what you're trying to do is take a solution that may or may not contain ions, and you're trying to precipitate them out by adding soluble salts to that solution. Sometimes you're adding the soluble salts to determine whether or not other ions are in that solution, and sometimes you're purposely trying to precipitate certain ions out. What you're seeing on the right here is called an analysis scheme, and it's just a way to keep track of what you're adding to the solution and what is being precipitated out. So let me go through a problem with you just to show you how this works. In this first sample problem, it says, to a solution containing ions silver, iron, and calcium as nitrates, a sodium bromide solution is added, giving a precipitate. So what I have in this box here shows you the ions that are already in this solution that we're going to be adding things to. So we're going to add some sodium bromide, which is a very soluble salt. And what we want to do is take out your solubility table here and look up which of these three ions is insoluble as a bromide. So you'll go here and you'll look up under bromide, we'll look up silver bromide. Oh, it's right there. So the silver must be the one that's going to precipitate out. You can also look up the iron and the calcium just to be sure they don't also precipitate out. Nope, the iron is aqueous and the calcium is aqueous. So it looks like it's going to be the silver. So right here we're going to write AgBr. If you want to, you can write a little S there. What comes down here are any ions that remain soluble in the solution, as well as any that we added that weren't part of the precipitate. So we no longer have the silver, but we have iron 2. We've got calcium. We now have sodium added to that. And we've got the nitrate. Going back to the problem, it says after A has been filtered out, so this silver bromide is A sulfide solution of potassium is added to the filtrate, forming a black precipitate B. Well, this is the filtrate. So when we took out the silver bromide, we would have had to filter it out. The filtrate is the solution that comes through the filter. And we're adding, again, a solution of potassium sulfide. So KS. And potassium's +1, sulfide is -2. And what we want to do is see which of these ions, iron or calcium, is insoluble as a sulfide. So go over here, I'll look up sulfide, I'll look up iron 2 sulfide, and I'm seeing that that's insoluble. Just to double check, I'll look at the calcium. Calcium sulfide decomposes, so it's not going to form a precipitate. So I've got the iron 2 sulfide is my solid, and what remains in my solution is going to be the calcium ion, sodium ion, the potassium ion now that I have in there, and the nitrate ion. Okay, so this is precipitate B. After another filtration of this precipitate, which means we took out the FeS, a sodium carbonate solution was added. So I'm adding sodium carbonate. And now we form precipitate C. So my guess is that calcium carbonate is going to be insoluble. I go over here, look up carbonates, look up calcium. I'm getting an insoluble. So I write CaCO3 here. What's left is a sodium ion, potassium ion, more sodium ions, which I don't need to write twice, and some nitrates. These ions right here that never form precipitates are called spectator ions. Now, it says, draw the analysis scheme we just did and write net ionic equations for all formations. So I need to write the net ionic equations for these three forming. So the first one will be silver +1 plus Br -1 forming silver bromide. This is aqueous, aqueous, and solid, and I just continue with that. Iron plus 2 plus sulfur minus 2 yields iron 2 sulfide. The ions being aqueous. It's a little messy there. That's AQ. And then the calcium carbonate is calcium ions plus carbonate ions forming solid calcium carbonate. And that is how you do a qualitative analysis problems. Some of the other problems have a little bit of a spin on them, but I think that should be enough to get you started with these. So good luck and have fun.